Right now, your attic is roughly 40 degrees hotter than the air outside, and that trapped heat is quietly draining your air conditioner every single afternoon. Nobody thinks about the attic because nobody lives up there, but on a hot day, it stops being storage and turns into a sealed oven sitting directly on top of your bedrooms. The air inside it can climb past 130 degrees, and on a dark, badly vented roof, it pushes closer to 150. That heat doesn't politely stay above the ceiling. It presses down hour after hour into the exact rooms you're paying money to keep cool. So, your air conditioner isn't really fighting the weather outside, it's fighting your own roof. And every afternoon, a little at a time, it's losing. There's a $30 aluminum dome that goes after that problem, and you've watched it spin on 1,000 roofs without ever knowing what it was for. It's called a turbine vent, or a whirlybird. It runs on nothing but moving air and the heat itself. No motor, no solar panel, no wiring, no monthly bill. Not this year. Not in 10 years. And in a measured field study, giving an attic a proper roof exhaust, like this one, cut its trapped heat by about a third. The part costs less than a tank of gas, and almost every contractor who's ever handed you a cooling quote somehow forgot to mention it. You're probably already thinking that something this cheap and this dumb-looking can't possibly do real work. Hold on to that thought, because the way this little spinning cap actually moves air is older and stranger than it looks. And once you see it, you won't walk past one the same way again. Let's start with the problem, because it's bigger than most people assume. Think about where your money actually goes in July. Cooling is the single largest chunk of a summer electric bill in most of the country, and a big slice of that cooling is spent on one thing nobody talks about, which is canceling out the heat pouring down from your own attic. You're not just paying to chill your house, you're paying to overcome a furnace you built into the top of it. And the size of that furnace is documented. Researchers at the Florida Solar Energy Center wired up the attics of 21 homes and logged their peak summer temperatures through the hottest stretch of the year. The homes that only had low vents down at the eaves ran about 35 degrees hotter inside the attic than the air outside. Picture that on a 95-degree afternoon. The space a few inches above your bedroom ceiling is sitting around 130 degrees, and it holds there for hours. If you've ever walked into a bedroom at 4 each in the afternoon and felt the heat radiating down off the ceiling like an open oven door, that's it. That's what we're going to call the attic heat trap, and you're cooling against it whether you ever climb up to feel it or not. So, here's the first number worth burning into memory: 35 degrees of penalty, sitting on your ceiling on every hot afternoon for the entire life of the house. Your air conditioner doesn't get to skip it. It runs longer, it cycles harder, and it wears out faster, all to cancel a layer of heat that a $30 part could be bleeding off the top of the building for free. Now, watch what happens when you actually let that trapped air escape. In the same research, when those attics were given a proper high exhaust up near the peak, the attic temperature fell from about 35 degrees over outdoor air down to roughly 22. That's a 13-degree cut from ventilation alone, with not 1 watt of electricity involved, and the heat conducting down through the ceiling into your living space dropped by close to 19%. Your air conditioner doesn't read that number off a chart, it feels it as real minutes it no longer has to run every day all summer long. And it isn't only the monthly bill. An air conditioner forced to grind through long, hard cycles against a baking attic doesn't just cost more to run. It dies younger. Heat is what wears these systems out, and a unit short cycling through the worst part of every afternoon is aging in fast forward. So, those 35 degrees up in your attic show up on your wallet twice. Once on the bill, you pay every month, and again on the replacement compressor, you end up buying years early. Pulling that attic temperature down is one of the few moves that hits both problems at the same time. So, if a $30 cap can pull that much load off the most expensive appliance in your house, why isn't it already screwed onto every roof in the country? Why did the company that quoted you $4,000 for a new condenser never once mention the little aluminum dome that would have taken strain off the unit they were trying to sell you? The answer is mostly money, and it isn't even hidden. A turbine vent is a one-time $30 sale. No refrigerant, no service contract, no annual checkup, no reason for anybody to ever drive back out to your house. A central cooling system is the exact opposite of that. It's the recurring revenue, the callbacks, the replacement parts, the maintenance plan. When the cheap thing that takes strain off the expensive machine costs less than the trip charge to come look at the expensive machine, the cheap thing quietly slides off the bottom of the sales sheet. There's no villain in a back room here. It's just an upsell nobody on the installing side has any reason to protect. So, over the years, everyone simply stopped bringing it up. But the part that genuinely surprised me is how old this is. The physics behind that spinning cap was patented before your great-grandparents were born. In 1910, an engineer named Samuel Ewart filed a United States patent for a wind-driven cowl, a rounded cap with curved vanes shaped to catch a breeze and spin. It's patent number 979390. Pull up a photo of a whirlybird on a roof today, and you're looking at Ewart's design, more than 100 years old, almost completely unchanged. The science was never lost, and it was never erased. It just was never profitable enough for anyone to put it on a billboard. The same physics those FSCC researchers measured with modern sensors was sitting in a patent office drawer when the Model T was new. And these were never fringe gadgets. For most of the last century, spinning turbine vents were standard equipment on factories, warehouses, barns, and workshops. Anywhere a building baked too hot to work in. And nobody wanted to pay to power a fan. Walk through any old industrial stretch of town, and you'll still see rows of them turning on the rooftops. They faded out of new houses right around the time central air became the default, and not because they stopped working. A powered system was simply easier to sell, and a passive cap had nothing to upsell behind it. The technology didn't fail. It fell out of fashion the moment there was more money in the alternative. So, what's that 100-year-old cap really doing up there? It's quietly doing 3 different jobs at once, and most explanations only ever get one of them right. The job everyone sees is the obvious one. Wind hits the curved vanes, the turbine spins, and the spinning blades sling air outward and up, dragging attic air along with them. Simple enough, and it's also where most people stop and then decide the thing must be useless on a still day. That's exactly backwards because of what happens next. As air slides across the top of that spinning dome, the pressure right at its throat drops. Fast-moving air is low-pressure air. That's the Bernoulli effect, the same rule that holds an airplane up in the sky and pulls smoke up a chimney on a gusty day. The higher-pressure air packed into your hot attic gets shoved up and out through that low-pressure opening, even on a soft breeze that barely turns the vanes. The turbine isn't blowing your attic air out. The pressure difference is pulling it out, and the spin just deepens the pull. Engineers call the narrow throat of a shape like this a venturi, a pinch that speeds the air up and drops the pressure even further. It's the same trick an old carburetor uses, scaled up and bolted to your roof. Then there's the effect that keeps working even when the air outside goes dead still, and this is the one that matters most. Hot air weighs less than cool air, so the superheated air pooled at the very top of your attic is always straining to rise. Give it a clean exit at the peak, and it leaves on its own. lifted by nothing but its own buoyancy, with cooler air sliding in below to take its place. That's the stack effect, the same force that makes a chimney draft and a hot air balloon climb. Your attic genuinely wants to breathe out the top. For more than a century, this $30 cap has been the cheapest way ever invented to let it. Put a number on the airflow, and it lands. A standard 12-in turbine is rated to move a few hundred cubic feet of air a minute in a steady breeze, and it does that on 0 watts around the clock all summer, asking for nothing. Wire up a powered fan to push the same volume of air, and you're paying for every hour it spins, which is a strange thing to do when the wind will do the identical work for free. By now, you've probably heard the skeptics, too. The people who swear these things barely turn and are a gimmick. But they're missing the one detail that counts. Even on a windless afternoon, when the cap isn't spinning at all, it's still an open chimney at the highest point of your attic, and the stack effect is still pushing hot air out of it. The spinning isn't the magic. The spinning is the bonus. The opening at the top is what actually does the work, and the turbine just turns a light breeze into extra suction on top of it. At this point, you're probably ready to grab a ladder. Before you do, there's one catch, and it's the single detail that separates a vent that saves you money from a vent that quietly costs you money, so don't skip it. A turbine is an exhaust. Its entire job is to pull air out. And for it to pull hot, stale air out of the attic, fresh air has to be able to get back in somewhere lower down. That somewhere is supposed to be your soffit vents, the slots tucked under the edges of the roof. Now, here's the failure mode nobody warns you about. If those low intake vents are blocked, painted shut, or buried under insulation, the turbine still pulls. It just finds the next easiest opening instead. And the next easiest opening is the gaps around your ceiling lights and your attic hatch, which means it starts quietly sucking the cool, conditioned air you already paid to chill straight up and out of your house. A vent doing that isn't saving you a dime. It's running your bill up. The fix costs almost nothing. You just make sure the air has a clean way in, down low, before you give it a way out, up high. The building code even hands you the ratio. You want roughly 1 square foot of open vent area for every 150 square feet of attic floor, balanced between low intake and high exhaust. The good news is that most houses already have soffit vents built in. They're just clogged. A $10 bag of foam baffles holds the insulation back so those intakes stay open. And that one small step is the whole difference between a turbine that pulls work off your air conditioner and one that hands it more. So, here's the entire build start to finish. And it really is one afternoon. You need one turbine vent, around $30 at any hardware store. You need a handful of foam soffit baffles to guarantee your intake is open. And you need a roofing knife, a tube of roofing sealant, and a ladder. You cut the hole up near the ridge where the hottest air collects, set the vent base in roofing cement, seal the edges so rain stays out, and that's the job. There's no wiring to run, no breaker to find, no permit fight, because passive ventilation is about the least regulated thing you can bolt onto a roof. A bigger attic might want 2 of them, but the math barely changes. The whole system costs less than a single month of the summer cooling bill it's going to spend the next decade chipping away at. And that's the part that should change how you see this. A compressor starts dying the very day you first switch it on. Every cycle wears it down a little, and in 10 or 15 years, you're writing a check to replace it. This is the opposite kind of machine. One moving part, no electronics, no software to fail. The only thing it ever asks for is wind. And wind keeps showing up for free. It doesn't degrade the way a motor does. It just keeps quietly pulling heat off your roof, summer after summer, long after the expensive box downstairs has been swapped out once or twice. Now the honest part, because this channel doesn't sell anybody magic. A turbine vent isn't an air conditioner, and it won't make your living room cold by itself. What it does is attack the heat trap, that 35-degree penalty baking on top of your ceiling, so the air conditioner you already own stops wasting itself fighting your own roof and goes back to fighting only the actual weather. It's a load reducer, not a replacement, and it only delivers if your intake is open, so do that part right. Get those two things in place, and a $30 cap spinning on nothing but the wind does real measured work for free for as long as you own the house. The heat was always going to build up there. The only real question was whether you let it back out or kept paying to fight it. If a $30 vent running on nothing but wind can starve your attic of heat, wait until you see the $80 solar fan that does the same job on the hottest, stillest days, when there's no wind at all. If this story changed the way you look at the hidden mechanics of your home, please subscribe and like the channel. We are uncovering the practical history and engineering that often gets buried. Let's build a more efficient future together. Our next deep dive into the tools that save you money will be opening soon.